Talk about H420, and this is using Wireshark, which is the main tool you use to analyze network traffic. So I'll open up Wireshark, and we want to examine this thing called FTP Login. I think I've already got it downloaded, probably even in my list of files here. FTP Login, there it is. All right. So you download the file and you open it in Wireshark, and now you see archived data. Now, if you look at the bottom right of the Wireshark window, let me see if I can get it to fit on my screen. Oh, by the way, you don't need a virtual machine. You can just install this directly on your host system if you like. It'll tell you at the bottom right how many packets there are, 298 packets, or 296 packets. All right. And up here you see the packets one by one that were sent through the network. Here's the protocol. Here's a summary of what they're at. So this is one way to get an idea of what's happening. Now, what we're going to do here, the next thing is to see I said I'd show you the OSI model here. So there is a TCP handshake. SYN, the local port 50681, a high-numbered port, is usually the client end of a connection. He's connecting to 443. That's HTTPS. So this is a web browser connecting to a site. It sends a SYN to the server on 443. The server sends a SYN-ACK back, and then the client will send a ACK, which it must be later down here, 50690. Must be somewhere later. There's other junk in the way. But anyway, that's the handshake. And so if you click one of them, like here's the SYN that originally connected to the server, then the middle pane here will show you the layers. So you have at layer 1, you have the frame, 78 bytes on the wire. That's the bits being sent over a wireless or wired connection. Then you have layer 2, which is Ethernet, and this has MAC addresses. So it's an Apple device with this MAC address talking to a destination, which will be a router with that address. Then you have layer 3, which has IP addresses. So it came from 172.16.40.104 and went to 172.217 and so on. So this is a local address talking to an internet server. And then it used TCP, with the source port on the client side being 50,000 and change, and the destination port being 443. So these, like I say, are the lower 4 layers of the OSI model shown here. And this is where you can see the raw bits in hexadecimal of the packet, and you don't use that very often. But this middle pane you use pretty often to understand what's going on with traffic. All right, so now if you want to find an FTP password, FTP does not encrypt passwords on the wire. So there's a lot of different kinds of traffic here. You can filter by putting the name of a protocol up here in the display filter, FTP. It will turn green when you've spelled a valid filter, and then you can press enter to make it take effect. And now if you look in the corner, you'll see there are 298 packets, but I'm only seeing 39 of them now, because only 39 of them are FTP packets. And now you can see the action here. It sends, starts with some kind of banner, then it says, please log in with user and pass name, and it does a request, then please log in. Here it says user John and password Flapper, and login is successful. So you can see this was the right username and that was the right password because you got the login successful result. All right, and so that's the first thing to do. Now there might be an unsuccessful login. If we go down further, let's take a look. Here there's a login. That was also successful. And it looks like that's all there is here. Okay, then it's going to transfer a file. All right, so that's all there is for that one. Now you can look for an HTTP password in this HTTP login file. So let me try that. File open. Cancel. I'm going to file open recent, see if I can get it. Because I have HTTP login on here too, which is right here, HTTP login. Okay, you can download it and double click it to open it, but I've got it. Now, I don't see anything because I'm filtering for FTP. And this traffic doesn't contain any FTP packets. So I have to clear that filter and press enter to see them all. Now if I look in the corner, it'll tell me packets 92, displayed 92. So here they are. And so you see it has various, there's ARP, Address Resolution Protocol, Network Time Protocol, here's some TCP, and here's some HTTP. So there are various kinds of traffic here again. And so to see the HTTP, we want to filter for HTTP. That's all we care about right now. So we filter for that, and now it gets down to 10 packets displayed out of the 92. So here it is getting a login page. It gets a 200 OK, meaning it found the login page and delivered. Then it gets the fave icon, which is a little picture in the corner, not very important, didn't find it. Now it does a post to log in, and the server gets it. Then it does another post to log in, and the server gets it, and another post to log in. So some of these logins might be successful, and some might be unsuccessful. And let me see the technique I want to do here. I did a post. You do a post, you'll see what was sent. Okay, so we're going to take one of these posts to log in. You'll see I have the layers I talked about before, 1, 2, 3, and 4. Then I have HTTP above that, Hypertext Transfer Protocol. And here I have the form data. So if I expand the form data, it will show you I sent it a username of Isaac and a password of Flapper. I submitted to a server. And if I want to see what the result was, the easiest way is to follow the TCP stream. Looking at packets this way is pretty detailed and specific. You're looking at the addresses and the time of every individual packet. But if you'd rather see an overview of the way this looked to the user, you right-click on a packet and then follow the TCP stream. And now, instead of showing you a lot of addresses and times, it will show you something resembling what the user saw. So here's the post that was sent with the username Isaac and password of Flapper, and here's the reply from the server. Now the reply is zipped, so we can't read it, which is annoying. And let me see what I wanted to do about that here. Yep, it's not very helpful because it's zipped. So what we can do is go back to HTTP, and we can view the reply in the middle pane. This is a way to do it. Wireshark will unzip it for us, but not in this view, unfortunately. So the way to do it is this is the post, and this is the acknowledgement. This is the reply. Remember, the server is the 172.16.1.129 that I sent it to, and here's 129 talking back to me right after I logged in. So this is the response. And even though the following of the stream didn't show it to me, here, if I expand it here, line-based text data, it will show me, you entered Isaac and Flapper, login denied. So here you can see it denied me, so that must be the wrong password. So there are several login attempts here, and you'll have to examine the response to each one to find out which one was approved. And then you'll know what the right password is. Let me check for comments in the Twitch. Nothing new. Okay, all right. Let's go back to the project, which is here. All right. All right. Then there's basic authentication. This is basic login. This is an attempt. Now, you notice the FTP and HTTP just sends unencrypted passwords right over the wire, which is, of course, a pretty unsafe policy. Let me clear this filter and load the third file, which is basic. Open recent. Basic login. There we go. All right. This was an attempt, an early attempt to fix that problem. So again, if I filter with HTTP, well, I got to use lowercase. All right. Now I try to get a secret, but it tells me I'm unauthorized. But the next time I get it, I get a 200 OK. So the way basic authentication works is you try to access a resource and you get this message, 401 unauthorized, and when you get it, your browser knows it has to collect a name and password from the user. So it'll pop up a box saying, give me a name and password, and then it will resend the get with an authentication line. So if you take a look at this one, this get, and you look at what was sent, it sent a get with a host and a user agent and some other things here. But notice there is no authentication in the data it's sending in the headers to the server. But the second get has this new thing called authorization, basic, with some base64 encoded data. That is the encoded username and password that was sent to the server. And since it's 200 OK now, that means the server accepted it. And so if you want to know what the username and password are, you just expand it in the middle pane, and it will undo this, and you can see it. But the point of this was it sends that mess over the wire, which is not as dangerous as sending the password unencrypted. Now, it turns out that it's really easy to reverse a base64 and find out what the password is. So it's not very safe anymore, but it was intended to be a step up from plain text authentication. Let me check for comments in the Twitch. No new ones. All right. And after this, there's a bunch of extra credit stuff that I got from a Capture the Flag contest, which is pretty advanced, this APT capture. And I'll show you just a couple tricks here. Some students are working on this one, and it's a good challenge. So let me get this one open. File, open, recent. APT capture should be one of my recently opened files. There it is, APT capture. All right. This actually is network traffic from a real attack. And so One thing you can do is analyze the protocol hierarchy. You can see what you can use statistics protocol hierarchy to see what kind of data was sent. Statistics protocol hierarchy. And this shows you all the protocols in use, and you can find out which protocols here are encrypted and what ports they're using. And you will find, if you can see the protocols, the ports are not easily visible here. I think even if I make the, we're not going to see ports here, but if I wanted to know, for example, what port was being used for SSH, I could right-click and apply as filter selected. And then I'll see the traffic, and here I can see here the port. It's going to port 22, which is what you expect for SSH. Anyway, so that's the first part. You have to find out what encrypted protocol was used on an unusual port, and then you have to find the tool that was used to form encrypted communications. And what you'll find is you can follow a stream of data, and you will see the actual commands the attacker executed on the system. And they executed commands to analyzed the system by listing the running processes and the files, and then they downloaded a encryption tool to the server and ran it, generated a key, and created a encrypted channel. And they did that over unencrypted traffic. So you can see the commands they used to make the encrypted channel, and you can even capture the key they created so you can decrypt that traffic. So it's a fairly advanced project. It's extra credit, but you do get to analyze an attack and figure out what happened. So it's a good thing to do, and I can help people with those in the help part of it, but I'm not going to demonstrate it to any extent right now. I want you to try solving it yourself first. So that's all I wanted to say about that. No new comments, so I'm going to stop this recording.